All right. So just trying to confirm, make sure that the audio is working, and we'll get ready to get the party started. Right. Okay. All right. Greetings, scholars. Greeting YouTube. Let's see. So we're continuing. This is going to be our third installment for College Algebra 1 from Morris Brown for the fall of 23. Okay. And so this is going to be the last section for chapter 1 on problem solving and critical thinking. And so with this section, we're going to be working on section 1.3, problem solving. Okay. Some objectives here are we like to solve problems using the organization of the 4-step problem solving process. Okay. So is that being blocked? Okay. So step 1 is to understand the problem. In order to do that, we read the problem several times. The first reading can serve as an overview. In the second reading, write down what information is given and determine exactly what the problem requires you to find, right? So the first step is understand the problem. Step 2, devise a plan. The plan for solving the problem might involve one or more of these problem-solving strategies. Use inductive reasoning to look for a pattern. Make a systematic list or a table. Use estimation to make an educated guess at the solution. Check the guess against the problem's conditions and work backwards to eventually determine the solution. Try expressing the problem more simply and solve a similar problem, simpler problem. Use trial and error. All right. Okay, that's fine. I feel like these are pretty self-explanatory. Step 2, continue. List the given information in a chart or a table. Try making a sketch or a diagram to illustrate the problem. Relate the problem to similar problems that you have seen before. Try applying the procedures used to solve the similar problem to the new one. Look for a catch. If the answer seems too obvious, right? Perhaps the problem involves some sort of trick. Questions deliberately intend to lead the problem solver in the wrong direction. Use the given information to eliminate possibilities. Use common sense. Okay. Let me get it. Sorry, totally distracted. Come on. All right. I think this is fine. We're going to let that be. Step 3, carry out the plan and solve the problem. Step 4, look back and check the answer. The answer should satisfy the conditions of the problem. The answer should make sense and be reasonable. If this is not the case, recheck the method and any calculations. Perhaps there is an alternative way to arrive at a correct solution, right? Yeah, I guess we started. That's fairly accurate. Like in the sense that what I mean is like, okay, if you're doing a problem solving or solving a word problem, you definitely got to read it once for an overview, and you have to read it several times until it kind of sinks in. It's definitely a good idea. It's a good idea to write down any information that's given. It's also a good idea to be clear about what the passage is requiring us to find, right? So then once we have a list of all the given information and we're clear about what we're trying to find, a lot of times you ask yourself, okay, is there some formula that incorporates the given information that helps us to find, that also incorporates what we're trying to find, right? And then if you find an appropriate formula, then you fill in what's given. Idealistically, you'll have one thing that you don't know in the formula, then you can solve, right? A lot of times you might have to draw a picture to organize the information or create a list or a table, right? Okay, let's see what else do we have. So it says a man purchased 5 shirts, each at the same discount price. How much did he pay for them? A man purchased 5 shirts, okay, each at the same discount price. How much? So then 5 times the discount price, right? Whatever the discount price is. So here's what's given that he purchased 5 shirts. We must find out how much did he pay for the 5 shirts, right? So the amount that the man paid for the 5 shirts is the number of shirts, which is 5 times the cost of each shirt. The discount price of each shirt is not given. So this missing piece of information makes it impossible to solve this problem, right? The closest we can get to a solution is say, hey, he paid 5 times the cost of 1 shirt, right? But we don't know the cost of 1 shirt. So by paying $100 cash up front and the balance at $20 a week, how long will it take to pay for a bicycle cost of $680? Okay, I like this one. So let's say we're at week 0, right? He's just starting out. So he pays the $100. And then what's remaining? So he's going to have $580 remaining. All right, that's how much remains. Let me see. And then he's paying $20 a week, right? So he did $100 up front plus the $20, right? So let's put the 20 here. So that's 120. So then remaining, I'll just put it here, remaining 560. Right? So then I feel like that should be week 1. Let me change that from week 0. I'm going to change it to week 1. All right. So the first week, he pays $120. He has $560 remaining. So then week 2 is what, another $20? So then he's going to have what? $540 remaining. Okay. I feel like this is behaving linearly. So what I'm going to do is fit this information to a linear model. All right, so I'm going to fit it to y equals mx plus b. Okay. So we can find the slope, right? We have 2 pieces of information. So we can do maybe how much the total amount he's paid versus what week it is, right? So for instance, the amount paid, do we want to do total amount paid? We could do total amount paid. So what? At the end of week 2, the total is what, 140? At the end of week 1 was 120. And then that's going to be week 2 minus week 1. Okay, so then that means that our slope is basically $20 a week, right? We had that information. And then to start out, right, in week 1, he pays what, a total of $120. So the y-intercept, okay, let's just do this. The slope is 20 times it being week 1. We don't know the y-intercept just yet. He's paid, at that point, he's paid what, $120 for week 1? So that means our y-intercept is 100. So then our model, if it's linear, looks like it's going to be 20x plus 100, right? So what this is saying is for week 1, he pays a total of $120. Week 2, by the end of week 2, he would have paid a total of what, 140, right? So now we want to solve for x. We want to see how many weeks will it take him to reach with this model. How long will it take him to reach 680? A total of 680, right? So we're going to set our model equal to 680 and solve. Okay. So then we have 20x. If we subtract 100 on both sides, we get our 580, and then divide both sides by 20, the number of weeks it should take, 60 would be 30, so 29 weeks. Okay. So what I did, I took at least two pieces of information. I got a sense that like the data is behaving in a linear fashion, and so I fit it to a linear model, right? So we got a total, after 29 weeks, he should reach his goal of $680 for this bicycle, right? Let's see how the textbook do it. So it says that we're given that the cost of the bicycle is $680. The amount paid in cash was $100, and then weekly payments of $20. Okay. So subtract the amount paid in cash from the cost of the bicycle. This results in the balance. The amount still to be paid. Divide this result by the weekly payments of 20 to find the number of weeks required to pay the bicycle. Long story short, you get to 29. So they kind of thought their way through it, and I fit it to a math model. And to me, that was the only way I can get it to make sense for me. So that's why I did it that way. Yeah. Right. But and we essentially did the same thing, because at some point I know we subtracted 100 and we got that 580. At another point, we ended up dividing the balance by the $20 a week to get a total of 29 weeks, right? So we did the same thing. We just kind of explained it in different ways. Right. So the answer of 29 weeks satisfies the conditions that the cost of the bicycle is $680. Okay. Now, why is that not here? If I go to this keeps changing. I don't understand. Huh. Does this anyway? Okay, well. All right, so let's look at this example on making a list. You are an engineer programming the automatic gate for a 50-cent toll. The gate accepts exact change only and does not accept pennies. How many coin combinations must you program the gate to accept? Okay. We want 50 cents and no pennies, right? So, all right. If we want 50 cents and no pennies, what's the smallest coin? So at nickels, let's start with nickels. How do you spell nickels? Is it like that? Hey Siri, spell nickels.
Nickels, N-I-C-K-E-L-S.
Okay. So if we only did nickels, you would have 10 nickels. So 10 nickels, right? Okay, we can do 10 nickels. Can we do 9 nickels? If we did 9 nickels, that'll put us at 45, and we would still have to use a nickel to get up to 50, right? So we can't do 9. We can do 8 nickels, right? 8 times 5 is what, 40? So then there's 10 cents left over. So we can do 8 nickels and 1 dime. Can we do 7? No, because that's going to be, we're going to be back to this one. But I think we can do 6 nickels. Right? 6 times 5 is what? 30. So then you can do 2 dimes there. 5. Okay, I think we can do 5 nickels. Let me see. Yeah. If we did 5 nickels, so there's 25 cents left over, and then you can do 1/4. Now, if we did 4, there's 20, so then there's what? 30 cents left over. You can do 3 dimes. All right. So you can do 4 nickels and 3 dimes. See, we're making a list of all the combinations. If we did 3 nickels, that'll be 15. So there's 35. So 1/4 and a dime. So you can do 3 nickels, 1/4, and 1 dime. All right. 25, 35, 40, 50, right? If we did 2 nickels, you would have what, 40 left over? You can do 4 dimes, right? And I think that's it, right? Because if you tried to get a quarter in there, 25 and 10 would be 35. You would have 15 left over. I think you would be back to the 3 nickels, 1 quarter, and a dime. If you did 1 nickel, 25, so a quarter and 2 dimes. So as far as nickels, it looks like we can do 1 nickel, a quarter, 1 nickel, 2 dimes, and a quarter. Okay. So that's focused on, that's the list focused on nickels. Let me go like this. Okay. Okay. So that's based on nickels. Let's focus on, let's try to get anything that we may have missed as far as what, dimes? That's not necessarily in this list on the left. So if we're thinking 50 cent, we could do 5 dimes. All right, and I don't think we have 5 dimes on the left. Can we do something with 4 dimes? 4 dimes, we've already captured it with 4 dimes and 2 nickels. Can we do 3 dimes? It's like we captured 3 dimes already. All right, I think we captured that. 2 dimes. Now what about if 2 dimes is 20, so then we still got 40. Can we, I think we captured that already as well. I was gonna say some other combination other than the 6 nickels. So it looks like we got all the combination of 2 dimes and then 1 dime. So we still have what, 40 cents? So we got the 1 dime with 8 nickels. We also have 1 dime, 1 quarter, and 3 nickels. I think we've captured all the 1 dimes. So I feel like we got all the dimes, and then with quarters, we might be able to do a 50 cent piece as well. I don't know if that counts. Quarters, we can do 2 quarters. And then I think we captured all the one quarters. We got 3 different scenarios with 1 quarter. All right, so I think we captured 1 quarter. Let's do a $50. Right, and then just 1 $50. I think that these are all of them. You know, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got 11 different combinations. Okay, let's see, how do we do? Understand the problem, the total change must always be 50 cents. We need to find all combinations using $50, quarters, dimes, or nickels. Okay, so that last little, hey, capture the $50 was a good idea. Carry out the plan and solve the problem. Devise a plan. Make a list of all the possible combinations. Begin with the coins of larger value and work toward. So we kind of did it the reverse. We started with a smaller value and worked up. Carry out the plan and solve the problem. We'll set up the table using $50, quarters, dimes, and nickels. Count the combinations in the table. Right? And I think we got all of these. We got 11. Let me see. 2, 4, 6, 8, 10, 11. Whoop, 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 whoop. Right, we got it. Okay, and you just gotta, you want to celebrate on some level, right? Just try to, you don't have to make it fun, but it's a lot easier to get through this content if you find some way to enjoy it, right? So look back and check the answer, double check to make sure you have all possible combinations, and it will add a 50 cent, and then double check your total count. Okay. All right, we're almost done with this section, not too bad. 4 runners are on a 1-mile race. Maria, Aretha, Thelma, and Debbie. Points are awarded only to 2 women finishing first or second. The first place winner gets more points than the second place winner. How many different arrangements of first and second place winners are possible? Okay. So we have 4 different women that we need to fit into 2 different slots. All right. So let me see. Here's we're gonna let this be first place, and we're gonna let this be second place. All right. So if we consider that, how many different choices do we have to put in the first? Well, either Maria could be first, or Aretha, or Thelma, or Debbie. So we have 4 different options that can go into that first position, right? So then now that we've chosen one of the 4, how many do we have remaining for the second position? Right. So if Maria is in first, then we have 3 choices that can be second. If Aretha is first, again, it's still 3 choices, right? So once we've chosen somebody for first, then we have 3 choices left over for second, right? So now, with each choice that we have for first, we have 3 choices in the second place. So whenever you have this notion or experience of for each choice in the first, you have X amount for the second, what that means is that we're going to multiply these results, right? So that means we're going to multiply. Times 3. So then there's a total of 12 different possible ways to have a different first place and second place winner. And you can actually list it out in the tree diagram. You can say it can be Maria is first, and then you can either have Aretha, Thelma, or Debbie. So that's 3 right there. Then you can have Aretha is first, and then you have Maria, Thelma, Debbie. That's 6. Or Thelma with the 3 options will make 9, or Debbie with the 3 options will make a total of 12, right? But again, the takeaway here is with the counting, whenever you have this notion of for each choice in the first slot, you have X amount in the second slot, that energy of for each means we multiply those results, okay? So we have a total of 12 outcomes, 12 possibilities. That's a little bit of introduction to counting. Okay, moving along, right? And so I think in the prepared notes, they're showcasing the tree diagram. If Maria's first, then you have 3 options for second. So those are those 3 combos, and these are all 12 different outcomes all listed out. So there are 12 possible combinations. It did kind of cover up my text over there. I mean, I could, nope, it's not even letting me do that. As much as I don't want it on the bottom, I think I'm going to have to put this on the bottom. Because usually that bar is there. I just don't like the way that looks. But we don't need that information down there. And that way, I'm not blocking things that I need to show. Okay, and I think that brings us to the end of this section. And let me go ahead and make a copy of this available. Share the box. This should be correct. All right. And so with that, you should now be able to access a copy of anything that you saw me writing. You want to use the box link it's in the announcement section on our dashboard, right? That's where I make the link available. And with that, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay. I'm more than likely going to go ahead and try to make chapter 2 available as well. So Okay, with that, we're going to end the session here. From one beautiful mind to another. Take care.